Do boop a doo boop a doo do 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 do. Wait, let's go get coffee. I'll be right back. I'm 2 minutes late. Dag nabbit. Where did everybody go? Everybody left. Oh, that was quite a marathon today. I just had, and I still need to do more. It's like a never-ending battle against the amount of things you have to learn. Good morning, everybody, or evening, or whatever your time is there. Today is this is a great chat there, everybody. Thank you for all that great chat. Boys like 30 minutes. Yeah, so we're going to jump right in because we have a lot to cover today. Just to give you an overview before we do dive in case you just joined the video. Number of logistics things. First of all, I got all the playlists updated on YouTube. So if you go to the YouTube site, you'll see right under the most recent posted videos is the only customization. It's just one playlist and it just has all the boost videos in it in order. And we're talking about the 2-hour videos. I noticed that actually adding in the highlighted videos from the first day made it harder to know what was next and stuff. So what we're going to do instead is I'm just going to, I know I know it's stuff you're going to have to like slog through, and fast forward and stuff like that. But I'm just going to do the 2-hour videos. I'm going to post those to YouTube and to Twitch, of course. And then I can do the highlights from those videos, later on. I can take those videos apart and pull them down and do whatever I need to do with them later. And then you can go to the Boost website or the Boost GitHub site, and you can click into the exact video on the topic that you want. You don't have to, look through because it's really not linear. I mean, some of it is linear, but a lot of the stuff that we're going to be getting into now with the Boost is we're kind of start diverging. And some of this stuff over here could be done at the same time as this over here. So having one linear playlist doesn't make sense for that stuff. But we do have an outline and you can quickly scan through that and get right to the video you want. If you want to watch everything chronologically, just go turn on that playlist and just keep watching. And, like your favorite episode of Netflix or something. I don't know. So who we have? We got 22 or so in the house today. All right. Well, today's a big day. Let's get right into it. We have I've been frantically working all day on my own workspace Docker file sort of system. And that's, we're not going to get into Docker files in this boost. And we're going to talk about that today. We're going to talk about containers, what they are, what is Docker and all that. All right. So let's jump in. So let me get back to the boost and set that as my default. Tmux in. So now we're in here and I'll be taking some live notes here. Again, you know where to go, right? So github.com/rdbxrob/boost. Make sure you watch that for changes, so you can be up to date on that. If you put an RSS plugin reader in your Chrome or something, you can actually be notified when there's a change. All right, so day 0, day 1, day 2 is the method. Day 3 is understanding the Linux approach. So, I'm not going to justify Linux anymore. Getting on the terminal. So yesterday we talked about all the different ways to get on the terminal, and I told you the different ways to consider doing it. Again, we're not going to cover how to do stuff unless it's not covered someplace else. And most of the stuff at the terminal is well covered around the rest of the internet. So I just gave you my take on what you might want to do and consider. Today is all about containers. And so let me make myself a little bit of room here. And it's not just today. The entire world of IT is about containers. So let's get ready for an actual movie. And I'm going to do my thing, and we're going to do the Pomodoro and do all that good stuff, so you guys can take breaks in between and not feel afraid. Okay, so we're going to do this as a video. Anybody have any questions before we start a video? You have any like informal things you want to talk about? 10 minutes in isn't too bad. You're going to be able to ask questions about every 20 minutes or so. So if you need to. How's my dog? The dog is fine. It's just me and she and I right now. The rest of the family's gone to different places, doing different crazy things this spring. So let's change the topic of the video. I can probably put it over here. What if I did that? Wouldn't that be cool? If I do that, this is going to actually wipe both my screens, though. I think if I do this one. I don't know about that. Let's try it. Let's see what happens. Let's see what happens, shall we? Oh gosh. That does not look good. Okay. I don't like that. No, we'll put the banner back. I mean, because reasons. You think I would be less finicky about this stuff, but alas, I have opinions. Not too bad opinions. All right, so let me. I need to make it at least a. Wait, let's do this. Let's do. Yeah, we'll leave some of this stuff up here. Linux distros, the work continues on our journey to terminal flow mastery. We're going to actually do that. We're going to copy that. We're going to do that right now. So I'm glad you asked that question. Very good question. Ranch OS is neat, isn't it? It really is. Yeah. No. Yep. All right. So, all right, you ready? Here comes the video. Mark. All right. So today is Container Day. And, in the old days, you would have called this Docker Day. And so we're gonna start out just by introducing the idea of containers. And the fastest way I can tell you what containers are is to help you understand what Kubernetes also has become. There was a blog post, and I'll let you do the research, or I'll put it in the notes or something. That was kind of inflammatory. It was last year, and the title of the it wasn't a blog post. It was actually an article. It was in Information Week, I think. And the title of the article was "Kubernetes is the new operating system." And the article goes into why the computer operating system is less important. And it actually makes a bunch of really interesting points about, even from a financial perspective, where all the money's going, what is becoming, and so to understand the statement Kubernetes is the operating system, the new operating system, you have to understand, first of all, what's an operating system, and then why would I care, and what are the things that run in the operating system? Spoiler alert: containers are the programs that run in Kubernetes as an operating system. Now, there's going to be a million people that are going to jump out of their skin right now because they're going to say containers are not just Kubernetes, blah, 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 blah. They're going to go crazy on that particular point. It's totally true. So let's just do a little history on containerization and why you should care. Containers are something that came about because of some advances in the Linux. Linux is an operating system. We talked about operating systems before. I don't want to go over that again. And I won't get into the technical details of what it was, but because of a few very significant technical advances in the Linux kernel, the main part of the Linux, which we talked about at length the other day, stuff was starting to be able to be run sharing the same kernel and the same hardware and everything, but in every other way, having all of the stuff, the other resources and processes and everything and files and everything be separated. And if you look at I'm not going to pull anything up, but if you look at, the Docker logo. So Docker was the first company / project to make containerization famous, even though it was being done all over the place before it got really picked up well by Docker. And Docker was pushing this idea of a ship with containers on it, and Kubernetes actually is a Greek word. I'll let you look it up. So the entire metaphor for containerization, like, putting containers on a ship and then shipping it out and pulling those containers down and doing whatever you want with them, that idea has really stuck, and that metaphor has really persisted. In fact, the icon for Kubernetes is the steering wheel of a ship. And LXC containers and how they're not Docker containers might be a good make a note of. Yes. So there have been a lot of, that's why I wanted to at least talk about that. The advances are coming in the area of Linux. And so the advances in the kernel in Linux are what gave way to the container movement. Now, it's important that you understand that at the same time as the container movement, actually shortly thereafter, virtualization was happening. And so virtualization is a completely different thing, but it is related. So a virtualization, we did talk about one of the best ways to run Linux. It might be to run it in a virtual machine. So this is, if you were to do this, you would download, VirtualBox or VMware, and you would run Linux or Windows or whatever inside of your other host operating system, and you would have a desktop and everything. It's all graphic. You can even play games in it. Solaris, Luminous zones, yes, all of that stuff. And BSD has containers now. So this is a boost. So we're going to stick with mostly Docker for now. But we got a lot of great people in the audience. Thank you for chiming in. It makes it more interesting. But so this was some time ago, and I would say it was probably 2012 or so. And I'm not a container historian by any means, but I just remember that like in 2000, 2002, 3, 4, that 7 by 7 definitely, we were using VMware to run an entire virtual machine inside of another computer. And then that became really big. You could do it, and really mainframe. IBM's been doing this forever. And so now you can just put it, flip a switch and, start up a computer, a full-blown, computer with the hard drive and everything. But it wasn't really there. It was just virtual, right? So that whole movement was going on. And there was sort of, at the same time, was going on this work for containerization. And before any of this happened, there used to be a thing called Shroot, which meant that you could protect, with, now that we have stuff running on our Linux computers that's dangerous and scary, you could have a program that's running, a service or whatever, be locked down, inside of its own memory space and its own file system space and everything. Linux jails, yeah. And you could say you can't break out of here. You cannot hurt other people. Sometimes they call people, it's called a sandbox. Basically, it's this idea because when the internet first came out, everything was running as root and nothing was locked down, and there was a lot of hacking going on. Nothing was encrypted or anything. It was, because remember 1996 in that time frame. Oh my gosh! I mean, it was just a security nightmare, and so then we had this movement, and so you fast forward to 2021, and not only have containers kind of won the day over virtual machines. People still use virtual machines, of course. Every time you fire up a machine in the cloud, on Amazon or Google or Azure or DigitalOcean or Linode or whatever, every time you fire up a machine, it's actually not really a machine, right? It's a virtual machine, and you can use that. But in addition to that, now we have this idea of containers, and why do you care? So for the last 15 minutes, we're going to talk about why you should care about containerization. So, and you can see some really great graphics. I've pulled them up before. I want you to do the work here right now. Make a note. Go look for images that compare, and make sure you can describe to somebody else who asks you, what is containerization versus virtualization? And we weren't going to have a test or anything, but this is to give you the idea of the thing you need to go learn. You need to be able to articulate to somebody what's the difference between a container and a virtual machine. Okay, they both have, you can put all of Linux, and we'll show you. In fact, I'll do it. This is actually really easy to demonstrate. You can put all of Arch Linux inside of a container, and now it's running. And I ran it. How many milliseconds did it take for me to start Arch Linux and run it? Believe me, this is Arch Linux. I promise. It's got Pac-Man and everything. If you've watched anybody else, there's no witch command. Oh my God, that's funny. That's Arch for you. How about Ubuntu? All right, let's run. Let's run. Something. I don't know. What do you want to run? So we could run Ubuntu or Debian, and we talked about different Linux versions and all that stuff before. So there's no Pac-Man here. So which apt? There's apt, and you get ls and all this jazz. So that's it. In fact, I recently put tmux inside of a container. Run tmux. So now, and I can set up whatever user I want over here. And now I have tmux. I have a bare bones version of tmux to use. And then I combine all of those containers together. And then I can create a workspace container that I'm currently working on. I haven't finished yet. And that workspace has lots of tools that I use all the time. But I wanted to demonstrate that to you because I want you to take notice of how quickly I was able to pull up and run a container. And the reason for that is because the containers are sharing, the main parts of the computer. They're running the main namespace, and they're using a service that's helping to run that. That's running on the computer, as a process. And we talked about that the other day too. How stuff works on Linux. Make sure you watch those videos. I don't remember what day it is, but you can look at the day. So why do you care about them? I mean, I promised I was going to tell you why. But I hope you're getting a sense of why just by watching me do it. Okay, so containers allow you, especially if you're a developer. If you're a developer and you don't know containers, it's like not knowing your coding language in the first place. You really need to know how to containerize whatever the thing is that you're running. So sure, you can run a program. But what if your program needs a lot of pieces? So these days, writing microservices is a big deal. Little applications that help web pages, applications work. I'm trying to keep the terminology kind of basic right now. Apologize to the advanced people out there. So what we're talking about here is that you've got. So let's say that, I mean, without knowing too much about how networks work and stuff, if you've used the internet, you know that you go to a website and you see something in your web browser and there's a bunch of stuff that happens, right? Well, you're using what's called a client. We're going to talk about networking later, but you're using a client in the web browser, and down behind the scenes on the server side is stuff that runs, that serves up all that data. Well, that back end stuff is talking to a database, and it's talking to a web server. It might have some middleware in between that, does some magic to the data before it goes up. And maybe it's even, going out to a separate service out over here and pulling in stuff from another completely different place on the internet. There's a lot of magic going on the back end of that application, that web application that you're using, and it's getting transferred over the internet to you. But yeah, the server to the client. So, but the point I'm trying to make with regard to a container is, I mentioned maybe 3 or 4 or 5 pieces of that server side that you can't see that need to be combined and managed like they're one. And that's where containers come in. So in terms of logical assumptions, for all intents and purposes, as they say, all of the stuff on the back end is one application combined together, right? It's the server side part of the entire application. In fact, the front end is often served up and included in the back end. Node very famously brought that to be, even though people are moving off of Node. If you haven't heard of Node.js, it's JavaScript that runs on the back end and the front end, but primarily the back end. We're not going to get down in that hole right now. We only got 10 minutes. But so where do containers come in here? Containers come in because you can take the database. The database can put it in its own container. You can take the web server and put it in a container. Or you can take the scripts that tie everything together and put those in containers. You can put the individual code in Go or Node or Flask and Python. And you can put all of that stuff all in the container. It's combined. Yes, it's combined. It manages. I'm glad you mentioned that. So separation of concerns is when you want to have everything not step on somebody else, right? So that's separation of concerns. So we have separation of concerns, encapsulation, and we also have the ability to combine everything. Now, the reason that containers are compared to programs, if Kubernetes can be compared to an operating system, containers can be compared to programs, in that when you write a program, you haven't written one yet, but maybe you have, but when you write a program, all of these same ideas are at play. So you want to put, these steps in this procedure, sign in or log in or change your password. Those are all separate little programs, so to speak, procedures, functions, whatever, within the same larger program. And they're all in the same coding language. And you're stuck with just that one language. So you can think of containers as the meta version of that. So containers are the meta version. So you have, you say, okay, here's just the piece that talks to the internet. Here, here's just the web server. Here's just the database. Here's just the code that talks to the database. Here's, whatever. And those pieces, so you can think of them as if they were, sort of functions or procedures or separate objects, and, in programming terms, and I'm really stretching here for the sake of making a point, and then putting those all together into the same program that, as far as as the end user, you just get a program and you run it. And that's what a container is. A container is all that stuff combined together, fully encapsulated, safe from everybody else, in a nice sandbox that has no access to anything outside of itself unless you explicitly grant that access. That means when when you run a program on your computer, and you can fire it up and have it answer questions from the internet and stuff like that, and give up secrets and all that kind of thing. Containers don't have that. By default, a container is contained. It's just, it's the whole point. So, and then you have to kind of punch holes through it. You have to say, okay, I want this container to be able to see this part of my hard drive, just this one file though, or maybe I only want it to see this one, socket, or this one port, it's called, for the network. And so you have to actually explicitly poke those holes when you run a container. So The most important thing to understand, and I'm actually gonna wrap up here. So the reason that you care about containers is because containers allow you to bundle up and encapsulate the stuff that you want to run, the stuff that you want to give to other people, and most importantly, the stuff that you want to develop while you're developing it. If you're a developer, you need to know containers. I used to, people would say, oh, I'm a developer. Why do I need containers? I just, all I do is write Java or whatever, or C# or something. I don't need to know containers. Well, if you need to get that code to run somewhere, then you need to put it in a container so you can give it to the people, the DevOps engineers, or whoever. So you can, in the old days, we used to call that throwing it over the fence, right? So you would write an application and you really didn't care about what it did to the computer underneath it. If you want to get a funny, comical version of this, watch the dynamic between Guilfoyle and Dinesh in Silicon Valley, the comedy. It's very rated M, by the way. I don't recommend that for really young people, but it's hilarious because it's this Dinesh is the golden child programmer, and Guilfoyle is the master operator from hell, the guy who has to keep the systems running. And so this dynamic between people who write code and create applications and people who have to support the systems that run their applications it's been really hilarious dynamic throughout the ages. And so today this has largely been addressed through the DevOps movement and through cloud native and through Kubernetes. And basically, this is what you do. You make an application, you write all the code, you put all the pieces, not just your Python code, but maybe you have other pieces that need to be in there, right? And some C stubs or whatever. You put them all inside of a container. And then you generally say, okay, well, this container needs access to these ports, and it needs about this much CPU, and it needs this much memory. And then you give that with all of those really great, metrics to the person who's got to run it. In fact, a lot of times that's automated these days. But you give it to them, and then they say, okay, this is how my thing runs. This is the parameters under which it's going to run. And so that container gets put in there. And if your application doesn't work because you didn't tell it what it needed properly, we can tweak it or change it and get it to run better. But it's on the developer's shoulders and the DevOps team to make sure that application gets contained properly so that we can manage this balance rather than just yelling at each other like in Silicon Valley. So that's the whole science, I suppose, and the approach of DevOps. But it's not just DevOps. It's more about handing off applications and testing those applications in the proper environment. You can get up and running in an environment, coding on an application within minutes using a container. So let's say you're a new person on a team, or you have new people coming to your team. You can create a container that's a fully encapsulated emulation of everything that the person needs to do their development in your environment. You can give them that container, tell them to put Docker on their computer, and they can code immediately as if they were coding the production product without any implications for the development. They can do all their testing, and you can just hand them off a container and they're done. If you change anything in your environment, you can change that environment and give them a new thing, and they just have to do Docker pull. 1 second command, and they've got the latest. This exchange and this being able to set up the development environment as quickly as possible is the biggest gain for I think for software development and software applications development. It's also the reason that software developers need to learn containers, and it's the primary reason that this boost is starting. The first technical day is starting by learning how to put Docker on your computer, and Docker, which is the primary user land, application for containers. And this is how we're going to start. So that's why you should learn it. That's what they are. If you guys have any other questions about this, let me know. But hopefully that will help you see. By the way, when just a little kind of an ancillary comment here. When remember I said that you need to hand off that container to the whoever runs your infrastructure, your operators as they might be called, your operations people. when you hand off that container and you say, I need X amount of CPUs, I need to use the GPU, I need a system that has 523 CPU cores. True story. I supported a group that actually has that many, has jobs that use 532 cores. So, or you can say, I want to use as many cores as you can give me, right? So that there, rather than just statically saying, this is the resources I need, and if I don't get them, I'm not going to work, or if there's more, I don't need more. Kubernetes enters the game, which is a technology from Google originally. It was called Borg once upon a time. The technology is pretty much throw a whole bunch of computers together into this hive and cause that hive to operate as if it were one. That's why it was called Borg originally, and then the open source version became called Kubernetes. But that's what they do, and it orchestrates the need for those resources. So instead of just throwing it over and saying, I only need 8 cores and never more than 8 cores, you can say, I need at least 8 cores. And so you set a policy, and then Kubernetes, just like an operating system, as I talked about on the Linux Day a couple days ago, you set a policy and say, I need, this much priority. And by the way, when you're running on an operating system, you can do the same thing. If you have a running program and an operating system, you can give it a priority. It's called a nice priority, a nice value. Well, it's the same idea with Kubernetes. I can say, I want this thing to run with at least 8 cores or more. And here's my policy. When it goes down, I want you to restart it and all that. So rather than giving these hard and fast dictates about how your application and its container should be run, all the stuff in it, you can now say, here's the general policy about how I want this thing to be run. And that is what Kubernetes is. Kubernetes is there. It is the operating system of containers being the programs. So when we give it a computer, a program, by the way, a couple of terms here with my last 45 seconds. A container, strictly speaking, a container is a running image. All right. So when you we're not going to make any during this boost, but other than the one that we're doing for learning the terminal. But when you're dealing with a container, you're dealing with something that's been created. It's an image. And that image, you can think of, if you've ever used a tarball or a zip or something like that, it's got a whole bunch of stuff in it. It's got whatever you put in it. But it's not active. It's not doing anything. It's inert. It's just an image. And then when you give that image to a system that can do something, that can run the image, whether it be Kubernetes or whether it be Docker or any number of these applications that use containerization, then it gets run. And when it gets run, that's when you tell it what resources it needs, what ports and stuff. And at that point, it's a running container. It's been instantiated. And that's the equivalent to a running process on your Linux computer or your Windows computer. It's a running process. Now, I can pause that process and say, I don't want you to do anything for a while. And you can do the same thing with containers. So a container, which is a running image, can now be paused. You can say, okay, I don't want you to run for a while. Or you can actually stop it or pause it, the same sort of term. And then you can start it back up again. And then you can use it again, however you want to do it. So I really want to punch this comparison between Kubernetes and the operating system and containers and programs, because I think it'll help you get your head around it. Some of you may be just getting your head around what is a program anyway, and how does it run, and how does it get managed in the processes. And for that, I really encourage you to go back and watch the Linux video. All right, I'm going to take a break. I'm going to take a quick break, but we're now off there. Let's see here. But also dev environments. Yes, that's what I've been containerizing right now. Was there no Docker before Docker? Yeah. No. Yeah. I let somebody else has probably got better history on me than I do on that. Is Taniwal here? I don't think Taniwal is here. He's the one to ask. Taniwal could give you an answer to that. Does that make sense? I'm trying to keep as many terms out, new terms out as possible, so that it sticks. because it was hard for me to get it too. And previous similar solutions. Well, there was other stuff. I honestly don't know why Docker. I think Docker had a better PR campaign. Also, I remember Docker presenting at a conference, and I think it was the first company that was built around containerization. And it definitely was the first company to host images. And we're going to do that next. We're going to talk about docker.com. Check out LXC containers. Yeah, LXC containers have been around for a while as well. In fact, I think LXC containers are pushing the containers idea even further from what I was reading recently. Yeah, it sounds like some really cool stuff there. But the containers are here to stay. And you know, we're still kind of on break here, but I continue to hear not just old people say, I don't need no stinking containers, Docker schmocker. I don't need that. Don't be that person. Seriously, don't be that person. I am so grateful that I came kind of late to the party for containers because I was running my own business and I didn't really need them. I thought, but now that I've started using containers, they have benefited every angle of everything I've done, including education. And as you're going to see, they are the best tool for experimentation possible. I mean, just today, I have 2 minutes left to just talk. So just today, I was like, I couldn't remember, at 7:40 I have to start. So just today, I could not remember if, I was like, where does Tmux live, right? When it gets automatically installed. So I went, no, it was Lynx, something like that. I can't remember. So I wanted to go see on Ubuntu where it lived. So I just ran an Ubuntu container, a fresh one, not one that I'd been customized or anything. I was like, where is, whatever. I can go look for stuff. And I was able to instantly refresh my memory about this thing by actually booting it up in like a second. The ability to go check stuff out or to actually go experiment with Pac-Man because you want to learn Arch, but you don't want to do a full-blown Arch installation. Or maybe you just want to sample the AUR because there's a lot of really great stuff in the AUR, right? In fact, if anything, and I've got a minute left, and this is going to blow people away who know me, I am now more motivated to learn Arch than I've ever been before because the operating system doesn't matter. Kubernetes is your operating system. Docker Compose, Docker is your operating system. You don't need to worry about your operating system because if you're running in a container, nobody really cares how you get your work done as long as, so you can build a workspace out that has Arch Linux in it and get all the benefit of the AUR. And the AUR has tremendous benefit over some of the other package managers that are out there. But the flip side of that is if I wanted, so check, I don't think I can do Red Hat. I don't think Red Hat has a container, do they? No, I didn't think so. Fedora would be the closest one. Fedora. Oh, yep, there's Fedora. So Fedora is a version of Red Hat, right? So let's say, I don't work with RPM. RPM is the package manager. We're going to talk about that today. But so Fedora has RPM and I can't remember the switches for RPM, right? And so I can go in here and I could I can install RPM. I wonder if it's in the man pages on there. Nope. But I can mess with RPM and do you see what I'm saying? So and then because they all have different ways of doing things and I can quickly test what those ways are with like one command. I mean, if you were doing this with a virtual machine, Yum is the other one. Yeah. There's Yum and RPM. They're different. Yeah. RPM is today. We're going to talk about that a lot actually. Yeah. OpenShift is Red Hat's Kubernetes. Yes, it is. Yeah. I know all about that actually. All right, so what's our next video? So hopefully that covers why you should care. Installing Docker. All right, so I've done another video on this. I'm going to do it really quick right now. Container for React. Yeah. We talked about the difference between a container and an image. I kind of got ahead of myself on that, so we'll do that one. We talked about Kubernetes as the new operating system. We talked about containers are the new programs. I'm gonna pump these in right now. Let's see. I talked about Linux distros matter less in a container world. We're gonna do more with that in a bit though. It's crude analogy to Lego blocks. Yeah. Except for they can talk to each other and you can plug them into each other, sort of, Kubernetes all the way. Docker Swarm is dead. Docker Swarm is a nice technology. So is Compose, Docker Compose, but Kubernetes, the enterprise has overwhelmingly adopted Kubernetes. So it's like beta. No, it's an old reference. You won't get it. As the API used to connect containers, are not a perfect analogy, but yeah, it really does. And by the way, before we get into this thing, I've been tasked with learning Kubernetes, and I've been really frustrated because there's so much to learn. And the more I get into it, the more I realize I am learning every single component, metaphorically, of an operating system. So if you are like me and you're trying to learn cloud native and you're trying to learn Kubernetes and containers and everything, which is all the meta level of the stuff underneath, you still need to learn the stuff underneath before you learn the meta level. It's daunting. It's daunting because there is so much to imagine becoming an expert in everything, including all the device drivers that run inside your computer. Well, that's what it feels like to become a Kubernetes expert because there's so many moving parts because it's an operating system. And if you think of it that way, it'll make you feel better about how long it takes you to learn the whole thing. All right. So let's come back to what about service meshes like on Istio? Yeah. I know of them, but the service meshes are going to be really interesting. Yeah. Because, okay. So he's asking about service meshes. There's a bunch of technologies out there that are helping all of the individual little containers that are running communicate. And so I don't want to go down that path. Actually, one of my favorite things to play around with is protobuf and gRPC. These are ways for things to talk really quickly to each other. And I'm trying to make a simple comparison. Honestly, the more this gets fleshed out and grows, the more, and the computer components are actually called nodes. The more the idea of graph theory comes to play. The REST APIs in the future. We'll see. I mean, we'll see. I mean, I think eventually it will. So, but the beginner, back to the beginner speak. Okay, so, as more and more containers are running. So I work for a company that has over 200,000 nodes in its Kubernetes cluster. 200,000 nodes connected to the same Kubernetes cluster. And they are all interacting. Those nodes, which are just computers with all the stuff that comes with a computer, they're all constantly running different things, different deployments. They're running containers in different combinations. They're running them as services. And all of this stuff is talking to each other. And if I could say one thing to help the beginners as they enter this cloud native space is to think about, a neural net or a brain. And in fact, in many ways, we are recreating the infrastructure of the brain. And what I find to be really fascinating, I won't get down, it's hard for me not to go down this tangent, but as we build out the infrastructure that is literally, like the electronic digital equivalent of human brains, and at the same time, we are making advances in machine learning that uses that type of framework and infrastructure. We are building Skynet. We are literally building at the same time. There's people working on getting all of this hardware in this particular infrastructure to communicate and to learn and all kinds of stuff. And then we also are building out the infrastructure to be able to put this on anything, including stuff that's smaller, like a robot. which is running a miniature little Kubernetes cluster called edge computing. By the way, edge computing is what we get when you have like your car. Your car is a little universe of a whole bunch of stuff talking to each other, right? And so you would put a Kubernetes cluster inside of your car. I'm oversimplifying, but you get it, right? And so you have a Mars rover. It has a Kubernetes cluster with each one of its sensors has its own node, its own computer in it, and they all talk to the central Kubernetes brain and coordinate through meshes and communication. And so what we've built is we've built the operating system, the meta operating system that can be run combining a bunch of different computers that are running in many, many different ways. And as the number of computers increases, there's a new computer in your toaster, there's a computer in your refrigerator, a computer in your toothbrush. I mean, it's getting so crazy that the little ecosystems of how these computers talk to each other will be managed by Kubernetes or something like it. And so learning this technology is going to take us to the next level. And so we actually, it's very frustrating IoT, right? So, but we had to have, is building the Terminator dog. Yeah. So, but you know, if the Terminator dog, for example, the Boston Dynamics stuff, it has so many independent little sensors and stuff that have to operate really quickly. And I don't believe they're using Kubernetes right now, but the idea of Kubernetes, you know, orchestrating and managing as so right now the policies relatively are pretty simple, but as the policies about how things are done and managed within this ecosystem of nodes and container programs that are running on there, as that improves, we're going to start to see really dramatic advances in what's going to eventually become organic computing, because it's just really amazing. Yeah, it does. It took straight out of Evelyn. It is. Okay. So that was kind of a long break, but I do want to talk about these things because part of my purpose here is to help you find motivation to do this stuff. And I mean, if it doesn't, if coding, you know, the brain and nervous system, as containers for, you know, you'd have one container for each one of those sensors potentially, you know, as if doing that for like the next Terminator dog from Boston Dynamics doesn't excite you, or, you know, doing it at a macro level and, you know, orchestrating, like, imagine what it can do for cybersecurity. There's an entire branch of cybersecurity. If you want to get really rich on pen testing, build yourself out a Kubernetes cluster at home or in the cloud and point every one of those nodes at the internet and have it, you know, actively process the whole internet, synchronizing all of its communication and stuff, and then just cracking all the things and reporting to you. Just sit back and make money. I've read articles about pen testers who do that as hobbies. That's what they do. They build their own Kubernetes cluster at home, or a hybrid, including, you know, stuff they have from wherever they get their hosting provider, and then they just point that thing in the internet and sit back and rake the money in. It's crazy. And these days you can actually get supercomputer power on AWS and some of these other ones where, which is actually really affecting security, because somebody can get a hold of your encrypted password file and they can buy like an hour of massive computing power on Amazon, and they can crack that password in 12 minutes. And this is actually happening. And then they throw away all the resources, and so it's becoming an issue because the hacker in the corner over there now has a supercomputer he can rent anytime he wants. so it's actually really interesting. The guerrilla warfare. I don't know about that, but I know. So the first thing you have to do to enter this world, hopefully that's motivating enough, is to install Docker. And I'm going to start a video for this. I did another video on this already, but I'm going to do another one. Okay. So, ready to go. So in order to enter this world, we've just been talking about Terminator and all sorts of crazy things that are coming about because of, containerization and, what that allows for the coordination of all these containers to talk to each other, including, you know, powering robots on edge or Internet of Things, all that stuff. So, and that led us to be, well, okay, well, let's actually get going with this. How do we do it? The first step to entering this world is getting Docker to run on your computer. And I mean, short of having a terminal, obviously, but the first actual container thing that you need to do, yeah. So the first thing you need to do is install Docker. And I've done another video about how to install Docker and stuff, but this doesn't have to be long. Just get it, okay? And again, the purpose of the boost is not to show you how to do it, it's to show you what to do and answer questions about, well, should it be this way or this way, right? And we have a whole community to help you there. So if I spend all the time showing you how to install Docker, we're going to be here all day. So there is overwhelming, you know, material on how to install Docker on your computer. So first of all, I'm just going to speak through the process for Windows, and I'm going to speak through the process for Mac and the process for Linux. Okay, so, and it's probably only going to take about 10 minutes. So for Windows, and we talked about this yesterday, the first thing you need is a terminal. And we talked about how to get a terminal yesterday. And then, no, we're going to use, for the purposes of this boost, we're going to use Docker. Okay. So there's going to be a lot of people that are coming to this who know more. If you're just starting out, just get Docker. Okay. Just get Docker on your machine. Whatever kind of machine you have. If you can, yes, you can. Yes, you absolutely can. And we're going to do it. I do it every day, all day. Yes, you absolutely can. You don't even need WSL2. So the first thing you need is, we're not going to talk about Containerd right now. So Containerd, if you hear people talk about Containerd and Docker and what's the difference, and don't panic, they're the same. Docker got kind of open sourced and became Containerd. That's the short version. It's not completely accurate, but that's the short version. And so if you have Windows is by far the most complicated of this to do. So step one, install WSL2. And there are lots of the information about how to install WSL2 is varies widely. Go get the most recent stuff, but I'll tell you the process boils down to, number one, making sure you have the latest patched version of Windows 10. That's probably where you're going to spend most of your time. You're going to be spending most of your time doing that. The second thing is you have to follow your scripts and stuff to install WSL2. And the biggest gotcha there is that people sometimes get hit with their hardware being too old or having a virtualization not supported in the BIOS, which means, unfortunately, this is the hardest part for Windows users right now, that if you get hit with this, you're going to have to boot your computer into BIOS. We talked about the BIOS on How Linux Works Day. And that's that blue thing, that sort of screen that comes up. You have to go in there and you have to figure out how to look through yours, and you need to go turn Hyper-V on. Yeah, and if you don't do that, WSL2 won't work. And the reason for that, the simplest reason I can give you is because Hyper-V is a hardware level OS virtualization that is accelerated. So remember we talked about all these virtual machines and stuff that came out in, I don't know, 2005 or something like that. All of that stuff ended up getting optimized and made speedier by the hardware people. And so then they started, instead of just using virtualization through software, they started to speed everything up through hardware, kind of like how every time you play a video game now, you use a GPU. Once upon a time, there was no such thing as a GPU, and all of those bullets and everything that you did on your first-person shooter were software rendered. If you remember back to the days of Doom, there was no GPU. That was all software, and it was slow. And so then that got optimized, and that got put into, all that stuff got put into, really oversimplifying, but it got put into a GPU, a graphics processing unit. And that was what led to, you know, the gaming movement. That's why you can do so many, you know, 4K screen full of microscopic, you know, smoke particles and have it render fine, because it's all really, really powerfully accelerated by the GPU. Well, the same thing happened to virtualization, and that allowed speeding up the containerization as well. And that's what Hyper-V is, hyper virtualization. So that is, you know, that is the manufacturer's kind of way of speeding it up. And not all boards, I think it's going to be turned on by default going forward, but we're going through this transition kind of where containerization and virtualization are standardized. It's been a decade at least, but we're still kind of going through this mainstream on everything. So there might be hardware that you have that doesn't have it. That's the hardest gotcha of that. Other than that, the WSL2, make sure you get 2 and not 1. Okay. And I don't even need to tell you why. You just want 2. 2 is true Linux, or the true Linux kernel. 1 is a Linux emulation. It's not even Linux. Okay. So 2 is an actual Linux kernel. 1 was a Linux emulation, and they threw it out and say, we're not using that. They turned it back on. There are some people have been asking about Hyper-V security, and that has been, there's been kind of an upsurgence in people concerned about hardware level security. So that's where some of that's coming from. I don't know if that's the only reason. I couldn't answer that completely, but there are a number of exploits that can be done at the hardware level. So, you know, that's why it's harder to boot your computer off of a USB stick these days and stuff like that, because, you know, you can't do like a Mr. Robot and, you know, Elliot goes in there and powers on a computer and reboots it on the USB stick and takes over the computer and bypasses all the security. But we're not going to talk about that. So that's for Docker. We got 17 minutes left on this. So I think I've covered all the Windows stuff. Right? If you've installed the Windows terminal, the next step after that is going to be, if you're using WSL2, I believe it is. It's one of my favorite all-time series of all time. It's very, very hard to watch. Very, very depressing and rough. But so make sure if you're in a happy place, it might destroy your happy place. I really like it though. So the next thing to consider is that when you're installing WSL2, is as soon as you get WSL2, it's useless until you have Linux. So you're going to kind of get sucked into the next stage of this, which is installing Linux on Windows. And that is not Docker container with Linux in it. And I know that's going to confuse people. I've been trying really hard to get around that. But when you install WSL2, what you want to do, most of you, unless you're blocked by your enterprise, most of you are going to go to your Microsoft Store and you're going to download Ubuntu. So after you get WSL2 on your computer, there's 2 things you're probably going to want to download from the Microsoft Store. You're going to want to get the Microsoft terminal. If you haven't already got it, make sure it's the official one, and Windows Terminal. Yeah. And the other, we talked about the terminal last night, and my video got muted because I played the music. You go watch day 4. And number 2, you need to have probably Ubuntu. So put Ubuntu on there. Ubuntu is hands down the most. We're in the middle of a video. As many distros as you want. Yes, you can. In WSL2, you can put as many distros as you want. Please don't get too distracted by this right now. You got a lot of stuff to do to get us through the boost, and then it's up to you to decide how much time you have. But this is the goal. So, so the goal is to get WSL2 installed, to have Ubuntu Linux on there, and to run that from a Windows terminal that you have possibly customized with your favorite color scheme. That's the goal. So by tomorrow, if not today, you need to have that done. And the next piece of this, of course, is going to be getting Docker on your computer. So, and that's what this video is supposed to be about. But there's so many steps to getting it so you can even install Docker. Yeah, you got to have the color scheme. People want their color scheme to stay motivated. So, so then you go to docker.com and install Docker Desktop, and that will be the final thing for you to do. If you want to do the tutorial for Docker that they have you walk you through, the Docker site, the Docker Hub site for Windows is just spectacular. It's really, really great. It gives you a whole interactive session. It even gives you a live terminal and shows you, what to do and how to do it. And it's going to cover a lot of those bases. And then, of course, I think tomorrow we're going to be really learning all the different Docker commands. And that's not part of this video. So that's a pretty long-winded explanation for Windows. I think most of you are going to be using Windows, and so you're going to need to go through those steps. Let's just recap them one more time. So install WSL2, and if necessary, tweak your BIOS to make that work. And then install Windows Terminal and Ubuntu from the store. Ubuntu for now. And then install Docker Desktop. And when you install Docker Desktop, it'll ask you, do you want to use WSL2 to speed things up? And you say yes. All right. So if I were to make any pictures or diagram or document about that, it would be immediately out of date because they're going to change that stuff all the time. So that's the goal. The goal is to get WSL2, Windows Terminal, we talked about yesterday, Ubuntu, Hyper-V activated if you need to, and then to get Docker Desktop installed. Okay. And I'll do another video about what to do with Docker once we get Docker Desktop installed. If you have a Mac, it's the same thing. Although today I just heard that Mac, I don't use a Mac anymore, but Mac users, you have the option to use Docker Desktop, but there may be some problems. So I'm going to recommend an alternative path for Mac people. All right. So that does not use Docker Desktop. So if you're okay, so if by that not tempted by the M1 Mac, no, hell no. Yeah, I was gonna say. So my recommendation for Mac users, so we haven't talked about Mac users. We're going to talk about Mac users for the next 10 minutes. Works for M1 now. There's an official release. Okay, so whether or not you have M1 or you don't have M1, Macs are a lot closer to Linux because they're Unix under the hood. So you can actually treat a Mac more like a Linux system from the beginning, and there is no Docker Desktop for Linux. So even if there is a Docker Desktop for Mac, you don't need it. So I'm going to tell you my recommended path for putting Docker on your Mac, and then you can decide if you want to play around with Docker Desktop as an alternative path. But the most supported way to get Docker on your Mac, number one, is to install Brew. And if you don't know what Brew is, go research it. Again, the purpose of the boost is to tell you what you need to learn and do, not to show you how. So number one, go get Brew. Thank you, Kangas. Get Brew. Brew is the lost window manager. Is it pre-installed? No, it's not. Is it pre-installed these days? That blows my mind. I didn't realize. I don't think it's pre-installed. No. Usually it's just one line command line you have to run, but I'd be really surprised if it is. Anyway, so you have to run Brew. We're not going to talk about all the other things you can put on your system with Brew. There's lots of other things. And so the second step after you install Brew is to do Brew install Docker, and you can go read about how to install Docker under Brew. Okay. While you're at it, can I just make a recommendation to the Mac users that's related to Docker that might make you happier later? I really suggest you install the GNU utilities. And, some of you are going to disagree with that, but if you want to use things like Bash from your Mac and not from Docker, that's one way to do it. This is not required for Docker by any means, but so number one, if you're a Mac user, install Brew. You should already know how to use your terminal. Figure that out, color it up, make it pretty, and then make it connect, make it install Brew. optionally install the GNU utilities, GNU core utilities, I mean, that makes it feel like Linux or anything else that you might be on BSD, because it's the same stuff. It's not some different version of it. And then Docker. So it's probably going to be a Brew install Docker. I don't know what it is, but go look it up and then get Docker on there. When you have it on there, then you're going to be doing all of your Docker stuff from the command line, and you'll be ready to go into the next video, the next part of this that we're going to talk about today. So this video is almost done. And this has been just a conversation about how is it core utils? Yeah, GNU core utils. Yep, that's the one. And if you're a Linux user, you've already had to go through, I mean, unless you're 0.01% of the people who bought a Linux machine from their store. Has anybody actually done that? I doubt it, seriously. It's probably unlikely. So Docker, I mean, it doesn't come with Linux, but it's just, there's a Docker installer to get it on Linux. I don't know if there is anybody here who is a Linux user from, so if for some reason you have installed Linux and you've managed to get that far on your own, because we're not covering that at the beginning of the boost, but if for some reason you're running from Linux, you will hit a hurdle trying to install Docker. There's many ways to install Docker. So yeah, but let me just tell you what I recommend for this. So I'm actually working this very thing. And believe it or not, it's actually not as easy as you would think to install Docker on Linux. I don't know why it's this complicated, but there are many ways to install Docker. And if you are a Linux user, my recommendation with the last few minutes here is to download this Docker installation script. So here's the URL. I'll post it in the chat. And you can go get it and you can run it. And you can curl it if you want. I'm not really a fan of that way of doing things, but I mean, I do curl stuff, but I don't like running stuff that's not been checked out first. System 76 is awesome. Yes. I love System 76. I wish I had one. Yeah, I had a bad experience with them in 2014 when I bought a laptop from them in 2014. I had to send it back. It was so underpowered. So there's a bunch of stuff here. By the way, if you're into shell scripting, this is a really well written shell script. So we're going to learn how to do shell scripting here over the next weeks or so. And we are going to cover all of shell scripting, basic POSIX shell scripting, because it's not covered online very well. So that is something I am going to cover. And it might take us a week or two to do that, but we're going to try it. So here's the script that you have to run, and you just run that script and that will get Docker on your system. And after that, you can do docker -- version and see which Docker you have, and you can have that. I'm actually building in case you're wondering, I'll just give you a hint here. We're not going to do any Dockerfile stuff, but to any of you who know Docker, just a little shout out to you here really quick. I'm actually in the middle of creating a workspace container that has kind and hyperfine and a bunch of, it's like my preferred workspace for development. And I'm building this out as a Docker image that then you could just run by just doing run rwx rob/workspace, and you would just get everything that I love to use all at once. I thought I'd call it a base, but it's got configuration files in there too, so it's not just a base. So that's one way, eventually you guys will be able to do this kind of thing too. So and this is relatively new. Put build out inside of that image. Yeah, I might need that in there. I don't know if you guys have any good. Yeah. So I think that would be great to make those compliant images if you don't have one. So, oh man, thanks for the cheers. Really appreciate that. So here we have, we need this Docker file. It's not ready. It's not ready yet, guys. It's almost ready. I tried really hard to get it ready for today. I didn't make it. So, but I just wanted to put that out there, kind of a tantalizing thing. If by tomorrow, so this is one of the reasons I'm doing this is if you want my workspace, oh, it's huge. It's really, I haven't even checked. It's got to be, yeah, it's got to be over 80 gig at this point. I mean, it's got so much stuff in it, you know, but this is like everything that I use every day on my terminal, and I just have to run it and it's all there. So it's like installing Linux without installing Linux. I'm actually making it for work because where I work, I need to take it and modify it. I did make a number of other things too, though, and like I mean, anyway, I'm off track here, but I have a little bit of extra minutes. So this is one of those things I was trying to tell you: the advantage of containers. I can put all of my favorite applications, all of my favorite script plugins and aliases and even full blown applications, including browser sync and npm and Node for that. That's the only thing I need it for. $100 bounty, by the way, if you rewrite browser sync in Go, I'll pay that. Because it's the only npm dependency I have. I can put all that stuff into a single container. It's a big container, right? It's a big container, but it's a container that's basically my workspace anywhere I want to go. And then I can just fire it up on Windows or Mac, or if I'm at a computer that's not mine, I can actually run my entire workspace instantly by just grabbing it off of just installing Docker. That's the trick. You have to have Docker on the system first. So $100 to shout out in my LinkedIn. I totally would do it. I would totally do it. So that's the end of that video. Get it on there. So if you're Linux, the answer for if you're a Linux user is a good chance you already know how to install it. But I just want to tell you that I personally recommend running the Docker install script. And that's how, if you have Linux, that's what I would do. And then the last way, well, I mean, that's really it. I don't imagine anybody's running on Raspberry Pi or anything like that. We're not quite ready to do all of this stuff on Raspberry Pi. In fact, the Raspberry Pi world, is as awesome as it is, it's just not going to be robust enough for a while, because most of the Docker images that are out there are AMD 64. This changing. And M1 on Apple is really changing that. They're going to start to see more and more images support ARM architecture, but for right now, it's kind of AMD 64 centric. So it's so really, and for the boost, we're only talking about how to get it on Windows, how to get it on a Mac, and how to get it on a Linux machine if you happen to have one. All right. I need a break. Also the fact that SBC is full of embedded developers. Yeah. I'm going to stand up, and when we come back, we'll see if we can talk through the Docker, some of the Docker commands, so you guys can start playing around with it. Oh, single board computers. Right. Yep. Push in kernel RC to support M1? Really? Wow. That's good. They need to do that. That's the kind of thing he likes to do. Torvalds loves that stuff, man. He got into it because of the hardware. He does? Yeah. Well, look, the M1 is like the next generation of CPUs. There's no doubt. The AMD stuff is legacy at this point. So it's just a matter of time before all of our CPUs are running ARM. Yeah. Yeah, it's think about it. Think about how old the non M1 ARM stuff is. Those CPUs date back to the 70s. Late 70s, early 80s, 84 probably. I mean, that's a lot of baggage. That's a lot of technical debt. We're going to talk about Docker as root, but we're not going to get into that right now. You don't need to worry about whether Docker is running as root, but it is by default Docker runs as root because the daemon runs as root. If you installed it on Linux, I should probably do a video about how to do that. So actually 8.19. Okay, I have to go at 8.19. So if you have, I was going to say, let me go to my. So you have this. It's in the Docker file. No, it's in the install Docker file. So this took me a while to figure out. If you're working on Linux, you need to add this. You need to add. If you add yourself to the Docker image, you won't have to sudo every time you run it. So here you go. Custom health checks for Docker. I have not yet. No, I haven't heard of that. Why is the Windows Store Ubuntu needed instead of containerized Ubuntu Linux? Because okay. That I know that's a horrible question. I hate that this is the way it has to go. So I got to answer that question. I'm going to answer that question on a video because that's a really valid question. Yep, before we go, I'm gonna talk. I want to specifically address that because it's so important, and I hit it the hard way. Yeah, so but let's make sure other people hear this. Install Docker. All right, so I'm gonna do a small video about that. Right now. WSL2 or 1? First of all. No. All right. So, all right. Somebody asked a question, and I forgot to talk about this. Why am I installing Ubuntu on WSL2 if I'm just going to run Ubuntu from a Docker container? Isn't that wasteful? I'm going to be running 2 Linuxes on the same Windows machine. And the answer is yes, you are. And that's annoying. The short answer is that WSL2 tried to be all things to all people on Windows, and it can run. It is a container architecture. It's kind of a hodgepodge hybrid Microsoft mutation between Docker, which is nice and encapsulated and sandboxed and everything, and tries to do all this extra stuff for you. And if you want to see me really lose my stuff, go watch the YouTube video where I complain about WSL2. Because what WSL2 is trying to do is integrate directly with the Windows system by doing weird things with directory mounting and permissions and messing with firewall rules that don't work if you're on an enterprise Open Connect connection. It just causes all kinds of problems. And so that is the main reason. So, somebody has actually tried to get Docker to run Docker Desktop without WSL2, and it's really hard. It's just a matter of time before they force you to install WSL2 if it doesn't even come with it by default. So that's the reason. You kind of have to have WSL2 to do anything with Linux on your computer these days on Windows, because they kind of have a monopoly on how that happens. And I don't know. I've been talking a lot about whether they're going to make a fully Linux enabled version of Windows. The writing's on the wall. I mean, they just announced like a couple months ago the full X support. So they have graphic support now in WSL2, full graphic support for applications that are running. And it's just a matter of time before they pretty much do what Mac did with BSD Linux and take over. I mean, next step, but and they take over and they do it with Linux. The main reason that okay, so let me just give you a quick story about what got me. I thought I could get away with not using WSL2 on my work machine right here. And so I tried it. I got, WSL2 off, I did the installation, and I could almost get there, but two things I noticed got in the way. The first thing that got in the way was that WSL2 is way faster. It optimizes your Docker images. And so, but the question still remains, well, why can't I just run all of my stuff using WSL2? And that's the second part. You cannot snap back WSL2. There's nothing to snap. The thing about containers that we'll see is that you can do this stuff with, you can do this stuff with when you're writing code and stuff like that, and you make a mistake or you screw up your container. One of the greatest things about containers is for experimentation and all this stuff, right? And exercising and experimenting. You can totally mess up. If you want to look for a hack, you can find it and totally blow away your whole system with root access and do all kinds of stuff to your containers. If you do that to WSL2, you're having a bad day. Now, technically speaking, you're just impacting that one version of Linux that was put on there, and you could go get another one and put that one on there also. So you do have some sort of ability to back it up like that, but generally speaking, that's not the way people are using it. But the real kicker, and this will be the last one, the real kicker to this was when I went to use Docker within Docker. And when I went to bind mount, which means to make a file or a directory on the host system appear inside of your container, we're probably not going to get into that. That's some more advanced stuff for containers. For absolute beginner, knowing how to map, even though knowing what a volume is kind of a stretch. But the idea is this, if you want to make your container be able to see the same home directory that your host computer has, you have to do something called a mount, and there's with a -v, and there's lots of other ways. And when you do that, it's a lot harder to do that without WSL2. In fact, all the tutorials and everything online assume you have WSL2 on the computer, and this became really acute as a problem for me when I started wanting to do Kubernetes development and testing and stuff inside of Docker, which meant that I needed to use Docker inside of a container. And I know that's more than you wanted to hear, but in order to do that, you have to mount var run docker.sock, which is a file/socket, and have that appear also in your container. So they use the same the local Docker instance. And to do that without WSL2 is virtually impossible. It's not impossible. You can do it using Docker from PowerShell or from the command just batch, but you'd have to figure out how to get the paths to work using Windows pathing and all of that. So that was the thing that really made me keep WSL2 as the underlying, and you can't have WSL2 without having a kernel. You have, and Ubuntu is the one that I put on by default. So you have Windows, and then you have WSL2, which is running Ubuntu, and then you're running a Docker container inside of Ubuntu inside of there. So there's kind of a Matryoshka doll sort of thing going on, and that's fine. You won't even notice it. In fact, the thing that's even crazier about that is actually how much faster it is to do that when you have, it's like Dockerception, right? You would think that all of that layering would slow things down, but instead it's the exact opposite. So by having Docker running within WSL2 and having it be optimized to use WSL2, which is that little checkbox you're going to look for, that's what you need. And then that's all running inside of Windows, where you would be otherwise forced to use, totally ugly backslashes and all sorts of ancient, command line stuff. So WSL2 has its quirks and problems, but it still needs to be there in order to make your containers faster that are inside of it and to enable them to be run in ways that are flexible. That won't really matter to you as a beginner, but as you go forward, it will really matter to you because you're going to be wanting to have your containers. You remember all the holes we talked about punching into your container. It's contained, it's in a sandbox, but how do we open up a hole so we can like make it run our own web server so I can run, I can do web development on the airplane or something. This is all enabled by containerization and by WSL2, which is that's a long answer, I know, but that is the path that they're going for that. Yes, welcome. I'm going to go ahead and end this video and talk to the raiders. So that's what's up. Let's take I'll take a 5-minute break here. How's it going? Thanks for joining, Eric. Thanks. Appreciate the raid a lot, dude. Is there a case for Docker within Docker, just mapping net to /sbin? Without nesting Docker? Yes, there is. I'm going to answer El Deuterino. I'm going to answer that question, even though it's technically not a beginner question. And a lot of this, by the way, guys, the first time I've ever used Docker in a professional sense was 2 weeks ago. So just so you know, I'm coming at this pretty new myself. But I've already written my own images and I've got Docker files down pretty well now. I'm happy. By the way, I'm going to ask this question. We're going to talk about this when we get to the shell thing. The most important programming language. You remember when we talked about containers being equivalent to programs and Kubernetes being equivalent to the operating system? Guess what the programming language is for containers? I know somebody's going to yell at me for saying this. YAML. No, it's YAML and shell. YAML, shell, and go. Yeah. Actually, YAML is not the language of containers. YAML is the language of Kubernetes, and it's the language of Docker Compose. But the most important language you will learn for making your own containers is shell, POSIX shell, which I think is amazing because I was already leaning on teaching POSIX shell as a first language because it's already intuitive because you use it every day. Every time you enter any line on your computer terminal, you are writing an interactive program using the POSIX shell language or whatever your shell scripting language is. So it's the Docker as registry, it's the Windows. It is, yeah. So that really plays nicely. I mean, I don't know if you saw this, but if you look at my workspace, if you look at my Docker file is a language. It's an official language on GitHub. Yeah. Docker file is an official language on GitHub. And what is going on here? What's up with all these ampersands? That's short circuit logic in sort of an imperative way. The bottom line is this Docker file syntax, Docker file has its own syntax, but the stuff that you write, I don't know, it's categorized as a language for whatever reason. Actually, I just read a thing today that said it was categorized as a declarative language. So it's just as much a language as SQL is. In fact, there are a lot of similarities between Dockerfile and SQL. If you've written a lot of SQL, you know that SQL has to be embedded in other things a lot of times, and so you get these things that have two languages in them. And run file, these Docker files, that's exactly what you get. You get this kind of meta syntax, which is declarative. It's like the reverse of SQL, and then inside of it, you get shell. And now I could, if I wanted to put Python on here or something, I could, but nobody does. Nobody does. If you look at all the Dockerfile stuff, 90% of every Docker file I've ever looked in is written in POSIX shell. So I used to think that the language for cloud native was Go, and if you're going to write cloud native applications, it is. But the language of Docker is POSIX shell, hands down, hands down. It's POSIX shell. Yeah, you can use anything. You could if you did Python in here, you would have to use the Python interpreter, right? You'd have to do Python-C. If you wanted to, you could install up here. What you could do is you could do apt install Python. Like here, I am installing curl, right? I have to install curl before I can use it down here to pull in all the stuff using curl, right? Or you can do this. You can write installers and stuff in Python and then run them that way. You can just run them that way. You can run them in Perl scripts. You can do whatever you want if you run it this way. But you don't want to have lots of runs. I'm going to get rid of these. You don't want to have lots of these because every one adds another overlay and it inflates your container and makes this container so big I don't care. But every single layer inflates it. That's what this is. This is multi-stage. So these all have their own builders. And it builds it, and then it copies the artifacts out of it, so that you can have individual builders for different things, and you can keep those up to date and stuff. So I love it. I mean, this is the thing I was missing from my dot files. So I promise we'll go back to videos. The thing I was really missing from my dot files was up until yesterday, I had all of my installers and my favorite. I mean, because come on, it's not always a deb install or apt-get, right? A lot of times there's some curling going on, and it depends on what thing you're installing. If it's if it's Go stuff, you have go get, right? And so I had a collection of installer scripts for all of this different stuff, and it always bothered me because it wasn't technically dot files content inside of my dot files repo. It didn't really belong there, and it was kind of like, hey, this is all the stuff that I put on there that all my dot files uses. It's configuration. In fact, once upon a time, it used to be home_config. I'm really tempted to call it config, but for searchability, I'm going to call it dot. And anyway, so yesterday, I broke out all of that installer stuff into a single repo, which is public. It hasn't been published yet, but and this is it. So, and then I have an entry point, and I'm really proud of this. So my entry point will go in and it will ask you your all your information so that you can synchronize your user account with whatever the one is that you want your user IDs to go with. Stuff super fun. So I just really love it, and I'm just trying to say. So I was able to take all of that installer crap out of my dot files and put them in this workspace repo, which just has installers in it. Yeah. And so then what I'm doing, I don't have it in mind right now. So I'm going to make, so this is just called workspace. But I don't know if I'm going to put it in workspace or I'm going to have dot files use this as a base. Probably though, I'm going to do this and I'm going to put it in here. And this is going to actually mount my config files as well. In fact, I had it working last night. I had it working. I ran the Docker container and I couldn't tell where I was because I was inside of my container that was completely configured like my desktop login system. It's super cool. It's like having just Linux, your workspace, your desktop. If you're a terminal person, it's like, and by the way, you can still mount X terminal. If you have X applications you want to use, all you have to do is bind the X sockets up, and you can do that. Just Frazzle does that in her video. So I'm just on these breaks, I just have to tell you, I'm super excited about this because I've always wanted to be able to just be up and running in a second anywhere. And not have to do all the installation, and that I've scripted that all up in my dot files and setup scripts and stuff, but that still is not ephemeral. In other words, if I run setup, I can't undo it, right? I have to go in there, I have to write an uninstall script, and it's really messy and dangerous. But if I run, in fact, I'm seriously thinking of just having a system boot and then running my container on top of that. Because if anything goes wrong with anything in my system, I can always snap back the image and I'm good to go. I'm exactly where I was. So it's super cool. It's like having your favorite Linux workstation with all of its customizations in your pocket, ready to get reinstalled anywhere at a moment's notice. I mean, it's just so cool. I just love it. I can't stop talking about it. I mean, the really great thing is if I have like, so say I was an independent contractor and I was working for 3 different accounts, right? I could have a workstation, I have a workspace on the same computer. On the same computer, I can have a workspace that is completely customized and built off of this base workspace for a particular client. And I can have another one that's completely customized for another client. And I can save those images. If I wanted to, I can make a doc file for those accounts, but I don't really even need to do that. I just need to commit the images as I go. And then when I want to work on an account, I just switch back and forth between the containers. If I make an update to my dot files, I go into my repos directory and do git pull and get all of my dot files changes to read only. And then I make all those changes. And now I have like independent separation, which is so great for so many reasons, including legal reasons. So, I've only worked on this account from this containerized workspace, period. That's the only thing. But I'm on the same computer. I got other stuff over there. I'm cutting and pasting between terminals possibly, but using Tmux, which is even better, right? Because you can actually have one container running in one Tmux window. You can have another container running in another Tmux window. You can have like 5 accounts or 5 projects all working on, logically separate computers by using Docker. It's just so cool. I can't. It's so lightweight. It's just so lightweight. It's not. If I was doing that with VMs, I'd be out of memory. I'd be out of memory after like the 3rd one. So yeah, one of those mirror effects that goes forever. It kind of is that. It kind of is. It really is. Yeah. Let's see. Is there are big data science images on Docker Hub that install Python, Pandas, NumPy? Yeah. Yep. And that's actually there is one for streaming too that will just fire up RTMP on Nginx, and you just run the thing, give it your stream key, and you can multi-stream to anything you want, just like that. And you just set your OBS to stream to that on your computer. I set that up in like 5 minutes because of Docker, because of containers. So yeah, I switch between them depending on the config I need. Yeah. Oh, wow. Check you out. That's cool, Billy. That's really cool to hear. Yeah. Connected to power switches. Oh, man. That is so stinking cool. That is so cool. Yeah. Virtualization might be a little easier there. Yeah. It would be great for monitoring multiple environments while working on another. Yeah, totally. Here's what's even crazier. Each one of those things can have different network settings. And that's an important thing. So, by the way, that's the reason I am so bent out of shape about WSL2. WSL2 decides on Windows, decides that it needs to have more firewall rules in place. So it does not work with VPN. You have to do a bunch of crazy PowerShell additions that trigger when the VPN is on and off if you're using the Cisco VPN. And it's a pain in the butt. If you just use a Docker container, though, it goes away because it uses your host, but you can also make completely different networking rules in your container. So remember I said like having like multiple containers running essentially different logical computers? They can all have totally different network settings. And so if you want to debug networking, I mean, I used to say you had to have, a virtualization in order to do network tests and stuff like that, to really get it a chest. But networking with WSL is a big gripe. That Kangas, that's exactly my gripe. That's my single biggest gripe. But you know what? It's so crazy. I did not expect this. But if you use a container within WSL, it gets around all of the networking problems. It's crazy. It's crazy. It bypasses them entirely. So because I don't know why, I think it might be using the host, which is underneath, and so it doesn't apply some of the DNS. Anyway. So if you're a network engineer and you want to practice with different IP stacks and stuff like that, you could spin up, using Kubernetes or using Compose, Docker Compose. Both of those are kind of ways that people would do that. You can spin up like 20 machines with a particular network configuration and have them all be in cluster, and they don't ever impact anything outside of that computer. And the footprint of all of those things, Docker Swarm, right? But Compose, you can sort of get the same thing. I did mean Swarm, but Compose, you can sort of spin up a bunch of things at once as containers. You could pull that off too. But most people would just stick with Kubernetes for that. The point being is that you can, particularly with Kind, you can fire up like any number of configurations for how the networking goes around. But again, with Kubernetes though, is it has really direct opinions about all the networking. So it kind of gets in your, if you wanted to be a true network engineer, as like, I just want a bunch of machines, I want to like do the networking myself. Kubernetes might not be the way for you to go. It seems like overkill to learn that to do networking, but you can just fire just with Docker only. You could, write a script or something and fire up, 10 computers with different IP configurations and then figure out how to make them talk to each other and mess with their IP stacks. You can also like turn on packet sniffers and stuff like that. So if you're in cybersecurity and you want to see how chatty an application is, you can turn that on and then have another computer, another Docker container that's connected. You have to connect the networks, make sure they're on the same network. But if you connect their networks, you can actually sniff all the traffic on that network. It's really cool. It's just so cool. It's just, you can basically, containers give you the ability to test every possible combination you can imagine, whether it be from an applications development perspective or network engineering, or even, file system configuration setups. And it's just an absolutely essential tool today. And I'm super excited about it. It's been really fun to do. It's also, it is a layer of complexity on top of, you have to understand how to use a computer in the first place, right? No vagrant yet for me. I'm gonna try that, do that next. So if you're a beginner, please don't feel lost. Again, I'm gonna recap the beginner goals. We only have like 10 minutes left. Web forms, yeah. Okay, so if you're absolutely brand new to this, let's first of all take a check and see if we're on how on track we are. We talked about that. Getting your first container. I think we're gonna put this stuff for tomorrow. I had a feeling it was gonna be today. All right, so this is kind of bonus work if you want to do this at home. I think this containerized world, and I think this is kind of a kickoff on containers. And so tomorrow will be what are entry points. An entry point. An entry point is an application that runs. Yeah, it's different than command though, because you can't bypass it. You can. You just have to use dash entry point. A bunch of stuff I'm learning about right now. So entry, yeah, that's we're gonna. It's too much. Roxio, if you're lost, okay. So to anybody who's lost here, the first thing I need to ask is, go back and make sure you watch all the videos. There's only, there's 4 days, so you could probably catch up. If you're lost because you're just coming in the room, that can't help you if you don't know what Linux is, if you don't know what a process is, and I'm building on the knowledge that we talked about in those previous days. So the end goal for today is to have Docker installed. And that will include you probably playing around with the tutorial, but that's not required for today. It's not required at all. You're the judge of you, but, or the boss of you. You can do whatever you want. But if you want to run your first container, you can go run docker run-it ubuntu, and then you can start to get into the command line. And that is what we're going to be doing tomorrow. Tomorrow we're going to be doing like docker run, pull, attach. We're going to go over the basic Docker commands. This is the part, the Docker tutorial is cool, is it not? Is it not? I mean, even for absolute beginners, it kind of holds your hand and shows you through how to do it. It does eat RAM. You can tweak that and stuff, but you definitely can tweak it so it doesn't use as much RAM. Besides from Go and JS, what other language would you tell a junior to learn back end? Shell. POSIX Shell is the most important language that we will learn. You're going to use Shell more than you use any of those other languages, because every single command you type in the command line is a shell command. Every single one. I'm starting to think that learning POSIX Shell is the most important language of the modern era, even though it's a really old language. I can't believe I'm saying that. It's so quirky and weird, but if you know it, I mean, what's the only other language you're going to use more? That remember how I used to make the argument that JavaScript is ubiquitous and it's everywhere, right? Well, what else is ubiquitous and everywhere? The shell. The terminal shell is everywhere. The most powerful language you'll ever learn that you'll use every day is the shell. And yet it's not taught anywhere. Anywhere. I have never once heard of anybody learning shell in any academic capacity ever. It's kind of like just assumed. I mean, I imagine some college level they probably have it. But anyway, so tomorrow we're going to be learning how to run our Docker containers. And we're not going to do Dockerfile and Docker Compose for now. Linux distros matter less in container world. So yeah, we're going to practice installing new distros. We probably will get some of the command line stuff tomorrow as well. I don't know which one to put up there. We probably are going to do navigate the bash command line interface. I think we probably would do that one. We're probably going to get pulled into package managers as well. I know that's what we'll do. That'll be fun. Yeah. Yep. So I'm going to put this stuff. It's going to seem weird to do that right away. People are going to start doing all this stuff. And they're going to be like, I want to do more. I don't even think we need to have all these commands. I only think the only command you need to do right now is run. I really don't need this. I'm going to change this. No, I can't. You have to have it because you have to be able to go start your thing. I'm afraid we're going to lose beginners on all the Docker commands. There's not that many, but they are really hard to figure out if you don't get told how to do them. I had to kind of trial and error it, and I could not understand the difference between pull, start, attach, stop, remove, and all that. So I think it's probably worth showing that difference. So I guess we'll go ahead and do that. Yeah. Recommend OOP language, scripting language. Yeah, I would not recommending OOP language at all. You got to remember, OOP is like way up here in the stack of languages that go all the way down to the kernel, right? Or down. So OOP is just one way to make sense of the world. I think it's so much more important for you to make sense of the world in a step-by-step way and then add on these object-oriented paradigms and things like that that are designed to help people understand complex stuff. When you're first starting out, there's not a lot of complexity when it comes to coding. It's like, do this, then do that. And I think it's really important to get that. And Shell is really good at helping you understand that. And then, when you start to need that kind of thing, you learn Python and maybe you learn some OOP techniques and your scripts are getting a little bit more complicated. You're just kind of growing into the need for more organizational tools. And so you're like, yeah, this makes much more sense to organize all of these functions like this, or it makes more sense to organize all of this as an object-oriented program. But you should pick the paradigm that matches the scale and purpose of what you're trying to accomplish. But at the lowest level, a computer just thinks about, give me an instruction. What's the next instruction? What's the next instruction? Should I go back and do that other instruction? That's it. So learning to think like a computer first is more important than learning how to make sense of a lot of complicated data. And that's what OOP is for. I think I should probably make a video about this, but I think one of the failings of modern computer science education is that they start with the high level paradigms. By starting with a high level paradigm, you're injecting onto a beginner this expectation that they are going to have a problem that requires very complicated organization of how stuff happens, whether it's an event paradigm or an OOP paradigm or functional. All of those paradigms don't make sense to beginners because they're designed to make sense out of very complex things. And they haven't even figured out the basics about procedural programming, imperative programming, step 1, step 2, step 3. Teaching somebody how to go stepwise through something is not only easier to learn, but it's closer to how the computer actually works, and it's closer to what you are going to do as you interact with the computer every day. You don't think about what kind of method should I write right now. You think, I want to see what the output of 2 plus 5 is, or whatever, and so when you use your computer every day, humans are thinking in terms of inputs and outputs. They're not thinking initially in terms of how am I going to organize this next task. They're only thinking about what's the next task at hand and did it work or not, and should I repeat it? And that kind of flow approach is really underrated today. And it's not procedural. It's not even, I think imperative is probably the closest word for it. All it is do this and then do this. It's just, and then if this, then do that. It's flow, it's basic step-by-step algorithms. And those are things that you need to get in your head faster than the other stuff. I kind of over talked about that, but for a few months now, it makes sense. And seeing how simply and powerful it is makes me want to give up on any OOP languages. Look, I think OOP languages have a real solid need in the industry, particularly for things. I mean, there's a lot of very, very complicated code that has to be organized, and like any game programming, right? Game programming, it's just a no-brainer to do that in C++, because at least it seems to me. I mean, I had somebody take me to task over this though, and they said it's actually not objects that you're thinking about. What you're actually thinking about is data-oriented programming for game development, where you just have a bunch of things that have stats, and then you have a bunch of events that are happening to those things. And sometimes you have things that are doing things to other things. And so, how do you track, who gets the action, right? So I know we've kind of gone off the deep end here with this last part of this boost, but I feel like we had a pretty good day. I don't want to overwhelm everybody. So as we wind it down, we only have 7 minutes or so left. So what are the goals? So by tomorrow, you should have a working terminal with Docker, being able to enter the Docker command from the command line. And if you want to, you can start doing the Docker tutorial. You can play around with the Docker tutorial. If you want to work ahead, learn how the basic commands from the command line, ls, pwd, and that kind of thing. If you want a book to start cheating with right away, there's a book called Learning the Linux Command Line, which has a lot of. It still is a really good book. It's dated, but it's not as dated as other things. There it is. So linuxcommand.org is a free book. I actually bought 2 copies of it, and it turns out I didn't need to, because it's right here for free. So the Linux Command Line by William Schatz. We used this book last year. We went through it quite meticulously. I'm not going to go through it at all this year, other than to say this is a good book to go through. So if you've got your container up, and maybe you've run your Ubuntu command and you have Ubuntu running and you want to work ahead, start just like reading through the Linux command line book, possibly. The entire book is available as a free PDF, or you can go buy it on No Starch. They don't tell you that it's free. It's like hidden right here. It's like it's available. Here it is. Free download this free thing. So here it is, and you can go get it. It doesn't have all the pictures and stuff, but this does have what is the shell, exploring the system. There you go. So this is all stuff you can do inside of your shiny new container. If you have WSL2 and you don't have Docker set up, you can even do this in WSL2 without running the container. But I'm still going to recommend that you get used to starting and stopping containers for some of your projects, because the process of installing things is going to be a big part of that. And we're going to be doing that. This manipulating files and directories, this is a really, really good right here. I would never cover hard links for beginners, but when we go through these basic commands, I'm eliminating a lot of the unnecessary commands just to get us through the boost. And over time, you're going to be adding a lot, which is why we talked about creating notes, creating your own Zettelkasten, and creating your own black book, whatever your method is. You need to start doing that because why? You're going to research and read about it, and you're going to write about it, right? You're going to write about how you like to do this command, what you need to remember from it, and then you're going to start exercising and experimenting with it, and that's what the containers are for. So this is something you can read to supplement your research if you want to do that. Okay. My favorite C book to date is Head for C for beginners. And I know that gets people very easy. No, the C. Ken Thompson is a horrible book. That's a horrible, horrible book. Don't get that book, particularly if you're a beginner. It's one of the worst books ever written. And it doesn't even teach you modern C. So, yeah, no, just don't. Just do Head for C. I was just gonna say you get people that are really pedantic, and they'll recommend you read the Ken Thompson book. Ken Thompson's a horrible writer. It's no surprise that he made Awk to me. He's a horrible writer. I'm just going to say it. We were so excited. I bought 25 in advance of his book on Go programming. And I was like so excited about that. And yeah, I was so excited about it. And I had a guy, yes, I did. Why are you here to troll? You're getting recorded, by the way, just so you know. My college C class assigned us to use K&R. Of course it did. Because it's college. College is still operating on old ideas. The Head for C makes bombastic assholes in college want to throw you out the door. Because it actually uses the science of learning by being silly and the same techniques that competitive memory people use to remember things. One of the techniques is to remember a story. So these people who remember pi out to 500 numbers, they do it by making a narrative in their head because our memories are visual and they're experiential. And so what they do is they make a narrative in their head of them walking through a town and having very distinct details that represent each one of the numbers. And then they replay those they replay those narratives inside of their head when they're reciting, and they close their eyes and they replay their dream that they've built for themselves, because the most lasting memories are those that are experiential or memory driven. And that's why we dream and stuff. And so, I mean, there's very, very good neuroscience that says that the way that the absolutely crazy, silly means that Head for C uses are actually substantial. And I know this because I did the same thing on accident. I was like always doing memes in my classes teaching students, and they were saying, we love that. I have never, ever forgot for loops because I associated it with badgers. We did a meme for badgers, right? So, so the college algorithms class right now. So the reason that I am so anti, black and white book with no memorable thing in it whatsoever is because it's not built to help you absorb the information and have you keep it in your brain. It's bad enough that you have to read it without, writing about it and then experimenting with it. But if you just have to read it, and K&R, black and white books are, and you know what? It's not. There's a reason that when you're a kid, I mean, seriously, there's a reason that when you're a kid you like the picture books. You like the picture books because you were able to create a narrative in your mind, a story that was a little bit helped by that. And if you're honest with yourself, the books and novels that you remember the most are the ones that you were able to create an imaginary world. I can still remember scenes from The Hobbit in my mind that have never existed for anybody else, because every time I read it very slowly, and I'm like building that world in my brain as I'm reading it. That's also how you learn other things. And so when Head for C, this absolutely silly book that would be thrown out the door by any bombastic, like full of themselves academic, those are the things that cause people to learn. But the institution for education doesn't accept that that's the thing. They write those textbooks for the people that they're selling them to, not for the people that are using them. That's the worst disaster. That's the most disastrous tragedy of the entire textbook industry. Almost every formal textbook that costs $80 is a total racket. It's written for the PhD, whoever, the high end, full themselves academics who have to make the decision about the books that's going to be used at their school. It's not made to be evaluated by the people who have to pay for the book and the people who have to read the book. It's one of my biggest pet peeves. One of my biggest pet peeves. It's one of the reasons I will never enter traditional academia. Yeah, I love the whole Head First series. In fact, somebody was telling me you could get the Humble Bundle. Humble Bundle had the entire Head First series for some like serious discount. I think RW Grimm was talking about that. Yeah. Like in case they reference it in homework. Right. Yeah. It says something about Head First C++. I don't know. I haven't read that one yet. I really like the Head First approach. It tends to be more verbose. Any book is not going to have enough things for you to do in it. The number one critique I get of any book is it didn't have enough exercises for me to do. Every single time I ask a young person, what is the thing you don't do or don't like? It didn't have enough projects for me to do. It didn't have enough things for me to do. And that's why on the first day or second day, we talked about how you need to get in the habit of building your own exploration, your own exercises out of the content. And the content doesn't have to be from any one of these books. You can actually make the content up yourself by researching the internet and build your own plan, kind of in an autodidactic way and write it all out. And then you can have a book to help you out. And you're like, well, this book is missing like a number of things here. I want to see if I can get good with doing this, right? So you might actually have to make your own things up. And when we get into shell scripting, I'm actually kind of conflicted about this right now. There's two ways to go into this, and I'm gonna tell you right now, I'm gonna stick with the way that I did with my Python classes in 2015, which is to take a really fun little exercise and be silly with it, and then to add in code that goes with it. Because by doing that silly little exercise kind of becomes the reference point mentally for the concept that we're covering. And I probably use the same old memes that I used to use because they're really fun. But it's totally silly. And some of the more, formal academics out there will just laugh at me. They'll be like, why are you doing that? Like, I don't know. We're just having fun with it, man. And why do we have to get so bent out of shape? You don't have to write theorems and proofs, to learn how to code. I mean, those things are substantially important when it comes time to proving an approach over another approach against another person who actually cares about whether this approach is better than the other one. But yeah, as we go through this, we're gonna be hitting a bunch of that. It's 9:03, so I'm gonna go ahead and go raid somebody. Who should we raid? I will be back tonight. I'm gonna be working on my dot files and my workspace container. If you want to jump ahead and look at some of that stuff, is in front of the screen reader, the entire book. A screen reader for an entire book. Yeah, it depends on the. Oh, you're talking about a book. Yeah, I know what you mean. It doesn't stick as well as, it's funny too. I don't know if there's any science to this. I truly think that there's this might be because I'm old and might be because it's true. There's something about having the physical part of a book that I think triggers different neural pathways in addition to what's actually there. And I know that because when I write and underline in a book, when I underline something in a book with my hand, I can feel the thing. I can see the letters getting underlined. When I select it with a Kindle or I copy and paste it and put it into my notes, into my Zettelkasten, then it doesn't seem to stick as well. And I don't know why. I want to think that that's because you're actually activating multiple different pathways in your brain that are related to the thing. And I, it's not politically correct to say that because it like makes books go away and stuff like that. But I don't know why. I would find myself like scribbling in the margins. The next best thing to that I've done is I've had a notebook when I'm doing screen stuff. when I'm reading stuff on the screen or my Kindle, I'll have my notebook, my physical notebook, next to my Kindle, and rather than doing anything on the Kindle, I'll write notes and I'll rewrite sentences. You remember we talked about the R or the W and RWX, right? I'll rewrite sentences, or I'll take my favorite passages and I'll put them in another book, particularly if it's on Kindle, because I'm not going to screw around with selections and all this stuff. So like if like there's a really, really good Go book that just came out that's Kindle only lately, and that's the only way to take notes. You either take notes in the Kindle or you take them in the physical, because you can't get a physical copy of the book, period. So I think having that might help. Yeah. Some people hate highlighting in books because it takes away from the book. The other thing that's bad about a book is you can't search it. So when you want to go back and find the stuff that's in there, but a lot of times when you have a book, it's not for searchability. That's a tough thing to say, because I mean, my O'Reilly book, I wish I still had that. I hope I can find that somewhere. It's got to be worth so much money. It's like Unix in a nutshell. It's one of the very first books that was ever out. I should probably wrap this up, but Unix in a nutshell. This was my first experience with anything with Unix. And no, that was not it. It's the old one, the really, really old one. No. This one. There we go. I have this original. It was printed in like 96, 97. When was it? Anybody else know this one? Unix in a nutshell. It's my first Unix book. Yeah. Updated for SVR4. AT&T SVR4. If you go back and watch the Unix Linux History Day, you'll understand that better. A desktop quick reference for System V. They would say System V too. They wouldn't say System 5. System V and Solaris 2.0. This is like before. Oh yeah. This is like way before that. This is when they were just starting out. They were just getting popular, and then they exploded. They exploded. Everybody had it. Referees, I know, isn't that funny? Oh, it makes me happy. It does. It still warms my heart. I have this book somewhere. I can't find it. I've had this book. It's one of the few books. You should see the edges of it, though. I mean, it has like how to use man in there, and how to use trough and nroff, and like really, really old commands that it's like a command reference. And most of it is completely out of date. It has how to do Bourne shell scripting and K shell scripting and TC shell scripting. All three of them are included. Yeah, it's really old. So, by the way, if you want to jump ahead and do shell scripting, I haven't looked at it yet, but I've been contemplating the POSIX shell scripting tutorial, which has been around for a while. To tell you the truth, I haven't ever gone through specific POSIX material. POSIX, it's actually been one of those things I've struggled with over the years, because it's hard to find a good reference. This one's been around there for a while though. So anyway, there's head first algorithms go. Is there? I don't know if I would have an head first algorithms. I would stick with mastering algorithms in C myself on that if you're going to do algorithms. But yeah. What else we got here? So POSIX shell file expansion, shell basics. I'm pretty sure this is going to be our standard material for POSIX. This tutorial has been around for a very, very long time. And it looks like it got updated. That's cool. It's not very sexy, but it's been around for a long time. And I like it because it's a nice reference to stuff. And it's a little bit happier than, look at that, 1994. I mean, this thing has been around a while. It was originally published in the Sun Observer. They, with POSIX though, you want the old stuff. You don't want any new stuff. I wonder what he does with the local operator. I know I'm off the rails here, guys. If you have to go, you have to go. I'm gonna call this, but I want to see if you put the local keyword in here, because I was just looking up if that's how you know somebody really knows POSIX, is if they don't put local in the list, and the shell check program doesn't do that. It's totally wrong. So I don't know if it's going to have it or not. Set environment variables, special environment variables, path, blah, blah, blah. This one. Oh yeah. So command expansion this is something I didn't learn until in my 40s. I didn't know that parameter expansion was a part of POSIX. Almost the whole time I was at IBM. Thanks for, hey Ivan, how's it going? Thanks for the feedback. I don't see it. No, it's not there because it's not a part of it. Ha ha ha. I mean, sometimes yeah. Anyway, I mean, like, why are we going to use this? If you really want to jump ahead and learn how to write POSIX, it's still worth learning Bash, but learn POSIX first, and then, then everything you do, all your scripts will work with Z Shell if you're on a Mac, or they'll work with whatever, right? It doesn't matter, because they work on everything. Echo shell. That doesn't always work, by the way. That's how you know you don't have an interactive shell. Yeah. All right, this is cool. I'm getting ahead of myself. It's time for me to go. Oh yeah, I was supposed to be rating somebody. Who are we rating, people? Who are we rating? Anybody have any hints? Is Mastermind on? I haven't seen him on in a while. Oh, Strager's there. Our regulars. Good old CM Griffing. He's awesome. Oh, hey, Dalright's on. I haven't rated him in a while. He's doing his cybersecurity stuff. I really love her too. Where's X? Who else we got? Nick Wan is on. He's great too, doing his data science stuff. Anybody unknown that we could go raid? I guess we could do Dalright. Yeah, he's doing a lot of the packet stuff. Let's go ahead and boost.
Very hard into the Linux
oh, Tanya was over there. Yay!
Linuxizing their Windows.
Yeah, we're gonna go chase Tanya down. Tanya wasn't over here because it's boost time.
No, they're not using the Linux kernel. Right?
I have to answer this.
What I mean is that
I'm gonna have to mute.
Like, you'll have to look up what they're doing, but they're essentially taking Linux as an idea and making it correct. But that eBPF might be a user, but it requires low-level control of systems, right? Like it's like the Windows Advanced Firewall. You need to be an administrator to modify that because it's doing low-level system control. Yeah, I don't really know the extent, so I'm like definitely ignorant to what they're doing around Linux, but they're doing something with Linux and Windows and putting them together. Hey.